Okay, welcome to 14.3. Put data into Venn diagrams and two-way frequency tables. So we have a list. You don't have to copy this table. Just tell me how many students had a curfew but did not have chores. Well, Frank had a curfew. Yes, for curfew, but did not have chores. Lacey had a curfew but not chores. And so there were two students that had a curfew but no chores. Now let's look at how many students had neither a curfew nor chores. So no curfew, no chores. So Karen had no curfew or chores. Stephen had no curfew, no chores. And Bob had no curfew, no chores. I think that's it. There are three of those. And we're going to put data like this into a diagram. So this is an example of a Venn diagram. So where the circles, we're going to have there's a rectangle every time, and in that rectangle are two circles that overlap. In the overlapping portion is where you put the people who have both curfew and chores. In the lower right-hand corner is where you put people who had neither curfew or chores, what we just did. And then each circle shows the people who have chores, but not the one of them, but not the other one. So chores, this number over here will be chores, not curfew, curfew, not chores. So let's see that. So this is the same Venn diagram we just had. And so we're going to sort the Venn diagram, sort the data using a Venn diagram. So you start by drawing a rectangle. And then you're going to draw two circles that overlap. Okay. And so let's start with the neither. So, and I'm just going to cross them out. This is Karen, we said, had neither, Steve had neither, and Bob had neither. So there were three people that had neither. Okay. The people that had both chores and a curfew, let's use a different color. Jane had both, and Sharon had both. So they go there. Then we're going to actually label the next one. We'll label this side curfew. Oh, I did it the other way, so let's do, well, I'm going to do curfew here. Let me get my eraser. So we'll do chores here and curfew here. And so the people who had yes for chores and no for curfew. So yes for chores, Stephanie, Pam, Dawn. So there was three of those. And then curfew but no chores. Let's use a different color for that. Were Frank and Lacey. And so there was two there. And that is how you sort things using a Venn diagram. So this data is called bivariate. Bi is a prefix meaning two. And so bivariate means variable. So it's a fancy word meaning two variables. The variables being chores and curfew, whether you had some people have a variance of those combinations. So let's try this one about people who play soccer and play basketball. Draw your own Venn diagram, pause the data, pause the video. So neither, two no's. There's person A, person C, and that's it. So there's two that don't play either soccer or basketball. All right, for both, I just see one. All right. For soccer, but not basketball, 1, 2, 3, 4. And lastly, for basketball but doesn't play soccer, 1, 2, 3. All right, and there are the 10. Is that a total of 10? Yes, a total of 10 students sorted into a Venn diagram. Another way to sort data is to use a frequency table. And this is a two-way frequency table. So you're going to copy this table down. And we're going to take the Venn diagram we just made and put it in that. It's showing the exact same thing, just in a different way. So let's look. So we're looking for people who played both soccer and basketball. And the people who played both, or is this one right here, was 1. Then let's do the people who did not play soccer, did not play basketball. That's this 2 right down here. Now we're going to look for the people who played soccer, yes for soccer, but no for basketball. So soccer, but no basketball goes there. And so what's left? We have the people who played basketball, but not soccer, go there. And that's taking a Venn diagram into a two-way frequency table. So we're going to do that next. All right, so there's the chores curfew 1. So you're going to copy this table and fill it in. And then you're going to answer the question below. So the people who had both chores and curfew, 3. People who had neither, no chores, no curfew, 2. People who had chores but no curfew, 3. People who had curfew but no chores, 2. What fraction of the people that had chores, so here are the people that had chores, had a curfew? So you need this total for this. There were 6 total people, right? You had 6 total people that had chores. What fraction of them had curfew? Well, 3 out of 6, right? So we're comparing the curfew to the total. And we simplify, obviously, our fractions. We always simplify our fractions. So half the people who had chores had a curfew. Sort the variate data using the two-free frequency table. This is about whether people have a dog and a cat. Pause while you do this. So 2 people seem to have both a dog and a cat. I like to go in this same order each time. So only 1 person had neither a dog nor a cat in this group, it seems like. Okay. Then let's use yes for dog, no for cat. So 1, 2, 3 had a dog but did not have a cat. 4 had a cat but no dog. Now let's answer questions. What fraction of the people that had a cat, right, there's the people who had a cat, also had a dog? So right, there were 6 total people. You just add up the rows, column there. So there's 6 total people who had a cat in this group. And of those 6 people, 2 of them had a dog, or 1/3 of the cat owners also had a dog, which means 2/3 of the cat owners did not have a dog, right? Because it has to add up to 1 whole. What fraction of the people that had a dog also had a cat? All right, so here are the people that had a dog, right? So the total is over there. It's 5. There's 5 total people that had a dog. Some had a cat, some did not have a cat. So 5 total people had a dog. How many of those had a cat? Well, 2 out of the 5, or 2/5 of the people who had a dog had a cat. So this is why what you just saw is why this is called a two-way frequency table, right? When we were doing, the cat, right? What did we say? The cat was 2 there, and this was 3 there. Is that right? Yeah. So when we were doing people who had a cat, we worked down, right? 2 out of the 6 cat owners had a dog. Then when we went the other way, two-way, right? When we were looking at dog owners that had a cat, notice totally different answers. One's 2/5, one's 1/3. So then people who do this sort of things would say, well, 2/5, right, is bigger than 1/3, right? That's right, 1 out of 9, this is more 4 out of 9. So they would say things like people who had a dog are more likely to have a cat than people that had a cat having a dog, which seems like they should be the same answer, but they're not in real world, right? Of the 5 dog owners, 2 out of 5, which is right, 4 out of 10, or 40% of them, also had a cat. But the cat owners, right, only 2 of them had a dog, which is 1/3, or around 33%. Cat owners were less likely to have a dog than dog owners were to have a cat. And that's what this is all about, those kinds of questions. All right, so the table's already filled out here, and we're saying what fraction of the people, so these are some candies, some were chocolate, some were not chocolate, some had a cherry inside, some did not have a cherry inside. So what fraction of the people that got cherries, so that's this group of 14, right, you add up, right, 14 total people, did not have chocolate candies, right? So it's the negative, so it's asking, right, there were 3 out of those 14. Of the people who got cherries, 3 out of 14 had a non-chocolate candy around the cherry, I guess. What fraction of the people that got chocolate candies, well, that's this group, right? We're going the other way. So we're adding up that total, which is 16. Out of those 16 people had no cherry. Well, 5 out of the 16 people who had chocolate candies had no cherry in them, which means, yes, 11 out of the 16 had chocolate candies. So this is typically what people want to know, right? You might have a hypothesis that people who buy sports cars, right, that go really fast, are likely to get in more accidents. Well, how would you prove that? Well, you would collect data in the real world and then see if people who buy sports cars rather than other kinds of cars are more likely to go in accidents. Let's see what this data says. We're asking what fraction of the sports cars had accidents, right? So we're looking at the sports cars. So there's 6 plus 26, right, which is 32 total sports cars in this study. And what fraction of those sports cars had accidents? Well, 6 out of 32. And we have to simplify our fraction. So it's, what, 3/16. So 3 out of the 16 sports cars had an accident. What fraction of the accidents were by sports cars? It seems like a similar question, but it is different. So here are the number of accidents, right? In this study, there were 6 plus 15, or a total of 21 total accidents. What fraction of the accidents were done by sports cars? Well, 6 out of 21, right, of the accidents. Right? Now, there were more accidents by non-sports cars, but think about the real world, right? Most people don't own a sports car, right? They don't own this high-speed thing going around. So there are going to be more accidents by non-sports cars because there's more non-sports cars. We're going to always simplify our fraction. and this is 2/7, all right? 2 out of every set accidents is by a sports car, all right? But, so that actually seems sort of high because probably 2 out of every 7 cars is not a sports car, right? If you look around, there's a lot of SUVs and minivans. All right, so that's the lesson. We're just going to practice. So we're going to sort the bivariate data into a two-way frequency table. Whoops. All right, so I'm going to draw it myself here, right? And so then you have, whoops, did I not do, oh, I did it myself. I didn't have to draw it. So there it is. And so both is 6. People who own both a dog and a cat, neither is 23 this time. People who owned a dog but no cat is 12. People owned a cat but no dog is 9. All right, so we've sorted into our two. This is a Venn diagram. And just like my last name, it has 2 ends. What fraction of the cat owners had a dog? Right, so the cat owners are here. Right, so you need the total amount of cat owners. And you're comparing that to the dog owners. Well, there were a total of 15 cat owners and 6 had a dog, right? And we're going to simplify our fraction, and we're going to get 2/5 of the cat owners had a dog. 2 out of every 5 cat owners had a dog in this study. What fraction of the dog owners did not own a cat? Okay, so we need the total amount of dog owners. So we're going the other way, right? And of those total 18 dog owners did not own a cat, right? No cat is 12. Again, we're simplifying our fraction. 2/3 of dog owners did not own a cat. That means 1/3 of dog owners owned a cat. What fraction of the people that didn't own a dog? So we've never done this before. So here are the people who didn't own a dog in the study. 9 plus 23, right, is what, 32? And so of the total amount of non-dog owners, we want to know how many owned a cat. So there's the amount of cat owners in the non-dog owners. And 9/32 is already simplified. And so that's the answer, 9/32.